it's
My phone! I'm suing.
yeah, okay. It's Gibson, and I am your AP Physics tutor. And today we're going to be going over work, momentum, power, and conservation momentum. Did you bring a pen?
No.
Pencil, paper?
No.
Alright, so first thing we're going to start off with is we're going to learn about work.
Work.
We're going to start out with this. We're going to start out We're going to start out with work done by a constant force is defined as a product of the component of the force in the direction of the displacement and the magnitude of the displacement.
Oh my gosh, I love One Direction. Do you love them too?
That's what work means.
One Direction.
And that's the first thing. Okay, so we're going to have to need to use the equation for work. So the equation for work would be work equals force times distance. Okay? So if theta is angled between the force and the displacement, then the new equation will be work equals F cosine theta displacement.
Theta? How do you spell that?
Theta. This
That's
is a
not
diagram of what it could be. This would be the force
I think you're
coming exerted from the object, and this would be the angle.
That is
theta.
right. What's this?
Second thing we're going to review is power. Power. The
How
first
long do you
equation for
think this
power is work over time. It's a ratio too, so it can be work, semicolon, time. Okay. Second equation is power equals force times velocity. An example of that is you're going to have a box, and you're going to have the force being exerted from it, and then you're going to have the velocity. Multiply those two together, and you would get power. That's power.
What am I here?
Momentum.
I'm never gonna use this in life.
Momentum is not represented by the variable m, it is represented by the variable p.
That's great.
So the equation would be p equals mass times velocity for momentum. Okay, so we're going to start with the conservation of...
Actually, I really don't care. So, like this says, I hate physics. Bye.
So I heard you're my tutor, and I'm really excited about this. I'm really happy I decided to do this because I was like failing.
Stop talking, please.
I was failing.
Stop talking.
Okay.
please,
Okay. So what is this? Is this the
Stop.
physics one or my algebra or English? I'm failing all of them.
Stop talking, please.
Okay.
Since the other girl left, we're going to continue where we left off with her. So
Yeah?
we're going to start off with by saying...
Okay. See, like I can't really read it, but I don't like when I have my glasses on. You know.
Can you
So
stop
should I put my
talking?
glasses on?
Can you stop talking? Thank you. Say another word and you'll be out of my classroom.
Aren't we paying you though? So
Yes. The conservation of momentum can be represented as, this is the equation, mv equals
Oh wait,
mv.
I'm sorry. Conservation is represented like what does that mean?
I'm representing it by the equation.
Okay.
Please don't cut me off again. mv equals mv, so that's mass times velocity
Wait,
equals
where did you
mass
get
times
the
velocity.
M from?
This is the equation that is given with conservation momentum. That's
Okay.
what you just asked me 2 seconds ago, asking
Okay.
if what is represented by. Don't cut me
Is
off
this
again.
supposed to be a star?
Don't cut me off again.
I thought like I'm supposed to ask
Equation.
questions.
Equation is mass times velocity equals mass times velocity. It's the same.
How do you know
before
that it's mass though?
and
Like what if it wasn't? What if it's like
after.
what if it's like gravity but they decided to use it as an M?
Hush.
Is gravity the thing that
Are you
I don't remember which one is which.
Are you going to let me help you?
Then stop talking. Can you talk to my teacher and like just
Elastic equation.
Okay,
gonna
like once
be-
I bought a rubber band and it said it was elastic, but it broke as soon as I put it on my hair. Is that the same as like is that what elastic's supposed to be like? Isn't it supposed to be stretch, right?
Elastic.
Uh-huh.
We're going to review the equation. This
Okay.
has nothing to do with your hairband.
Okay.
Please don't interrupt me again, or you will be kicked out.
Oh wait, is that the same M as this M?
No,
No?
it is not.
Okay, then I don't understand. How am I supposed to know which M is which? It's not fair.
M equals mass. So we're going to start with this. M1 plus times V1, plus M2 times V2 equals
So will it
M1
say like
times
M1
V1
is
plus M2 times V2. So this first part of the equation will be initial velocity. the second half of the equation will be the final velocity. So if you're using, like, say you're using this for an example, in the example, like, say you are giving the final velocity and only one of the initial velocities, you may have to
Is this
solve
your
for
handwriting?
just the initial velocity. Then, or it can be put as this: 1/2 m1 v1
I don't like
plus
fractions.
1/2
I don't
m2
like
v2
fractions.
equals 1/2 m1 v1.
My algebra teacher is
plus
always like,
1/2
leave it in
m2
fraction, leave it in
v2.
fraction. I'm like, why? Like, I
So,
don't like it in a fraction. She always
that-
says that. It's so rude. Always. Like, she counts it wrong on my quizzes. Like,
Do you
and she's
want-
like, why is it in a fraction?
Do you
I
want
said,
me to help you? Get out of my class.
oh, wait, I'm sorry.
Get out. Have a nice day.
No, wait, I want to finish.
Get to 7! No! Get out of my class! Get out of my class.
Like, so can I get my money back?
Get out and take your chair. It will not be refunded because you got kicked out of the class. Thank you. Have a nice day.
You're
On
not
a
a
very
very
nice
nice person. And I
Take your chair, please. Thank you. Okay. Since both of my students couldn't cooperate, we are going to finish what I started. So, elastic equations, you can do it with a second equation, 1/2 times m1 times mv plus 1/2 times m2 times v2 equals 1/2 times m1 times v1 plus 1/2 times m2 times v2. That is a second equation for elastic equations. Next one, the next type of collision that we have is called an elastic collision. The elastic collision equation, will be the same, have the same type of formula as elastic. It can be used for in elastic equations, but the initial like verbatim equation will be m1 times v1 plus m2 times v2 equals parentheses time is m1 plus m2 close parentheses times velocity. That'll be all for today's lessons of AP Physics of work, momentum, and conservation of momentum and power. Thank you. Have a nice day.
Okay, now we're going to solve some examples with these formulas in real life situations. In this example, we are going to calculate work. The equation for work is force times distance. And we know that force is also mass times acceleration. This example asks for us to calculate the work done if a 10 Newton force acts on a body and it moves at a displacement of 2 meters. So we need to plug in the values into our formula. So work equals, our force is 10 and our distance is 2. So the work is 20. Pretty simple. And this is measured in newtons times meters. And there you go. In this example, we are going to review momentum. Momentum can be solved with a simple equation, which is this little p looking thing, meaning equals mass times velocity. So if we have a motorcycle going at 40 meters per second, which is actually pretty slow, and weighs 325 kilometers, what would its momentum be? Well, we just need to plug it in. It would be 325 times 40. So now let's plug that in. And that would be 13,000, or 1.3 . And there we go. Now we're going to review inelastic collisions. All inelastic means is that momentum is not conserved and the kinetic energy is lost during the collision. So here, it would mean if masses are stuck together. So we have m1 plus m2 going at one speed, which should equal m1 times mv plus m2 times v2. So two separate masses going two separate velocities. So if we have an ice skater holding a girl, ice skater, and the guy throws the girl. Well, at first, it's m1 plus m2 going at one speed. Then we have, at the end, after he throws her, two different masses going two different speeds. So, both the boy and the girl go at a speed of 7.4 meters per second. The boy weighs 82 kilograms and the girl weighs 48. This would equal the girl's final speed times her mass, and the boy's mass times his final speed. So, we first need to add up 82 plus 48. This is 130. 130 times 7.4 is 962. Now we have 48 times her final speed is 8.6. Is this. So, to solve, we first subtract the 412.8 minus the 962 and get 549.2. And this equals the boy's weight times his final speed. Then we just divide. And this equals about 6.7 meters per second. And there we go. And that is the boy's final speed. Now we will review elastic collisions. This means the momentum is conserved and there is no kinetic energy lost. So, if two people are on bumper cars and they just bump into each other, they both then go other ways. They have two different speeds and two different masses during the entire time, but their speeds change. So we use this formula to solve. This first mass of the first person in bumper car is 86 kilogram person plus 125 go-kart. Then we have this person who is 92 kilogram plus his 125 kilogram cart 2. The masses stay the same in both problems, in both times of the collision. So M1 times MV plus M2 times MV2. So first we have, before the collision, we have 86 plus 125 as mass 1 at a speed of 2.5 meters per second. Then this next person, who is 92 kilograms, is not is at rest. He's not at any speed, so his speed is 0. So first let's solve for this side. So 86 plus 125 is 211 times 2.5. 2.05 is 432.55. Plus, we have 92 plus 125 is 207 times 0 is 0. So, now this side needs to equal the other side. So, we have again M1 times V1 plus M2 times V2. So, we have the same masses, but this person is now going at a speed of unknown. And this person is going at a speed of 1.4 meters per second. So we need to solve for V. This side equals 32.55. So we know that these added up is 211, and this is V1. Now 92 plus 125, we also know, is 217. Now we need to multiply that times 1.4, which equals 303.8. Now we would subtract this side to the other side. And get 128.75 equals 211 V1. Now we just divide, and V1 equals 0.61 meters per second. And that is how you use an elastic collision formula.